Okay, now, the second part, P of t. Helps get a pen. P of t is equal to the 100 plus the integral from 0 to t, and I have to change the variable now. So it's going to be 15 minus, it's 1/10 x dx. So that means it's 100, it's the same antiderivative, right? We just did this. It's going to be 15x plus 1/10 times, it is minus, I'm a flake. There we go, minus x squared over 2. That's bothering me, I gotta fix it. Yeah, because I'm doing t, hang on. And I gotta do minus 0 just to show you that it's minus 0, right? That's the advantage of this. We did a definite integral. We don't have to mess with the c anymore. So what's the equation going to be? It's going to be 100 plus 15x minus 1/20 of x squared. Huh? Do I mean what?
I don't see how you got the x variable. Like, how did you just...
I thought it was
Yeah, I thought you evaluated from 0 to t.
I did. Oh, it should be t's now.
Yeah, I was like, is it?
Yeah.
I was like, is it right?
I was being so careful about, okay, here's what I did wrong. I skipped a step because I got distracted.
Oh shoot.
So
Wait, what?
it's x like this, and I'm evaluating from 0 to t,
Oh.
right? So then I get the 15t minus 1/20t squared, and then minus 0. I don't have to worry about the minus 0.
Wait.
Okay,
Wait, so how did you...
that makes way more sense. I was like,
So I'm integrating with respect to x, so I get the antiderivative in terms of x, but I'm plugging in t.
In the initial
it's just a faster
problem, where did the range of 0 to 100, I thought that was like t is in between 0 and 100. Where did that factor in?
It's just giving you information on what the... All right. The reason we do that is because early on, many epidemics, pandemics, and any time of exponential growth, it's exponential growth. Anytime you're talking about that. The problem is, after the flu doesn't go on exponentially forever, does it? Eventually it flattens out. And that's called logistic growth. So the reason we say that is because eventually you're going to see something very similar, but instead of being all exponential growth, it'll be exponential growth to begin with, and then it'll be decay to a limited capacity eventually, and that's called a logistic growth. Looks just like it, but by limiting it, I kept it to the exponential growth part. They're just writing it. That's an AP question, and the only reason it's that way is because of the exponential growth. Okay, y'all are now ready for your quick quiz.